All right, so let's start with number one. Do you want to read this one out loud?
Does a car speedometer measure speed, velocity, or both? I would say only speed because velocity tells us the direction in which the object is moving, and I don't believe a speedometer gives you direction. It might be a different device on the car.
Yeah, perfect. So velocity is a vector and speed is a scalar. Perfect answer. Number two.
When an object moves with constant velocity, does its average velocity during any time interval differ from its instantaneous velocity at any instant? I don't think it would differ, because if it's constant, it would always be the same, and no matter when you pinpointed a speed throughout its journey, it would be at the same speed.
Yeah, awesome. Good stuff. Number
Okay.
three. If one object has a greater speed than a second object, does the first necessarily have a greater acceleration? Explain using examples.
So the speed is how fast they're moving at a designated time that we've selected. But acceleration, we would only be able to calculate that if we had selected two different points along the journey. So we could identify like, oh, it's going slower, oh, it's going faster. So the first might not necessarily have a greater acceleration because the second object could be accelerating faster and catching up with it, but we'd need more information to know for sure.
Yeah, for sure. Could you give an example of this using, say, cars?
Oh, could I do a bicycle? So a bicycle is coming down your street and a dog sees it, and the dog has just started to chase the bike, and the bike hasn't noticed that the dog is behind it. So the bike is going its way, and the dog is going faster and faster and faster, catching up with the bike. So when the dog first started, or when the dog was sitting, watching the bike go by, it might be moving at a slower speed. But if we calculated the speed later on when the dog was excited and getting closer to the bike, it might be going at a faster speed despite starting at rest or a very slow pace.
Yeah, perfect. Good stuff. So it is possible for the slower velocity to have a greater acceleration. Likewise, they could just both have zero acceleration because they're going at constant velocity, right?
Oh, so constant again, too. Absolutely.
Constant velocity. If I'm going 5 meters per second and I'm not accelerating, I'm going faster than someone with 1 meter per second speed. But we could both be constant, in which case our accelerations are the same because they're zero.
Oh,
So
okay.
there's a ton of examples we could use for that one, but yours is really good. Next up is number four. Go ahead and read this one.
Compare the acceleration of a motorcycle that accelerates from 80 kilometers per hour to 90 kilometers per hour with the acceleration of a bicycle that accelerates from rest to 10 kilometers an hour in the same time. Both of these scenarios accelerate by 10 kilometers per hour in difference. One from the speed of 80 kilometers per hour and one from rest. So the main difference is one is coming from movement and the other is coming from nothing.
Which one has the greater acceleration, if either?
I would think that despite being the same number of change, if you're already moving at 80 kilometers per hour, that would be larger.
The acceleration's going to be larger?
So is it the same? Because it's the same amount no matter if you're moving from rest or you're already in motion. I see that.
So it's all about the change in velocity. It doesn't matter your original velocity. It matters how much it increases or decreases over a span of time.